So you write down your problem statement. The fire hydrant is tested under a high standpipe pressure. The fire hydrant, this is the fire hydrant, is tested under a high standpipe pressure. Full stop. Is tested under a high standpipe pressure. Standpipe pressure. Standpipe is written together. So the total flow of 10 feet cube per second, the total flow of 10 feet cube per second is divided equally between two outlets. Between two outlets, each of which has cross-sectional area a cross-sectional area A as 0.04 feet square. The inlet cross-sectional area cross-sectional area at the base is 0.75 feet square. So this is outlet area. And this is inlet area. So let me summarize what I have said. The fire hydrant is tested under a high standpipe pressure. The total flow of 10 feet cube per second is divided equally between two outlets, each of which has a cross-sectional area of square. The inlet cross-sectional area. The inlet cross-sectional area at the base is 0.75 feet square. Neglect the weight of the hydrant and water within it. Neglect the weight of the hydrant weight of the hydrant and the water within it. Compute one, the tension tension T, the shear V, and the bending moment to bending moment at the base of the standpipe. At the base of the standpipe. At B. This is the base of the standpipe. Additional information. What is the additional information? Specific weight of water, rho. Actually not rho, it should be rho g. Specific weight of water is 62.4 pound per feet cube. Also, static pressure of water as it enters the base B, as it enters the base B is 120 psi. This is the problem which we need to solve, but before we do that, it is important to recap what we had discussed in the previous class, that if you have in general a container through which there is a flow of mass, The container can be a nozzle or a fixed tap, and there is ingress of mass and there is also outflow of mass. So at instant of time t, we assume that this packet of mass delta mi is entering. This is the mass of the entire system, including the container and all the fluid particles. And at t plus delta t, you are having, we identify a set of particles as the system at this instant of time t, and at t plus delta t, what happens? This del mi goes inside the container and there is a outflow of delta mo at t plus delta t. So we had these following equations. One was conservation of mass, where we had m dot I minus m dot O was equal to m dot, which is the rate of change of the mass enclosed by the container and its boundaries. And we applied Newton's second law of the form summation f into delta t, which is equal to delta g. This we further wrote as g into t plus delta t minus g at t. And we also had the definition of, there is on this container, you are having force F. This representation is the net of all forces acting on the container, and it comprises of the forces at the supports, at the attachments, and it also includes forces which may include the fluid, weight of the fluid and the self weight of the container. But here, for instance, in this problem, it is said that neglect the weight. And what was other forces? Static pressure, force due to the static pressure of fluid which is at the inlet or which is at the outlet, or both can be present. Okay. So we were able to extend Newton's laws for systems with mass flow as m into v dot. So at this instant, the velocity is v. At t plus delta t, the velocity is v plus delta v. Okay, this is at t. And this is the physical, these are the physical forces which are coming here. This is mass into acceleration. But now, since you are having a mass flow which is creating some momentum exchange, there will be what we call flow forces or impulsive forces. Okay. And for rockets, this also gives the thrust. Okay. So you can write it as m dot I. Sorry, what was the form? M dot O, relative speed of the exhaust as seen from the system. Exhaust means this mass packet. Relative speed of this mass packet as seen by someone who is sitting on the container, moving container, minus m dot I into v dot, the ingress mass, its velocity relative to the system. And other form of writing this is you write m dot O. What do you write? UO minus V minus m dot I UI minus VT. This is just the definition of these quantities. So what we did further was we extended this for steady flow and fixed container system, where fixed container is, the container's velocity is not there. So this v goes to 0. Acceleration also goes to 0. So we applied it to fixed containers and steady flow. When you apply it to fixed containers and steady flow, your m dot I minus m dot O becomes 0, which implies that m dot I is m dot O, and we call this some m dot S. Just a single word for the mass, rate of change of mass entering the system and leaving the system. Since it's a steady flow, the velocity field inside this container does not change with time. Okay. It may change with space, but it will not change with time. So the equation, let us call it, we can now call it 1. That time I think it had 8 or 10, some equation. So when you apply that, the steady flow condition, this is due to the steady flow. And then the second condition is fixed container, which gives v dot as 0, v also as 0. And you modify 1 as, so how is it modified? Summation F of all the physical forces acting on the boundaries of the container. So boundaries comprise as the fixed surface of the containers plus those points where the masses are entering and leaving the system. So this part is 0. If you look at this part, m dot O and m dot I are the same. So you end up with m dot S UO minus I. Similarly, for such systems, you can also have angular momentum conservation. If the inlet speed ui you know and there is some uo, you can take moment about a fixed point O having some d1 and some d2. What was the notation I had used for that? Ri, right?
Yes, sir.
Ri. So if you take summation of all the forces about a fixed point, I mean moment of all the forces about a fixed point, you get this about the fixed point O. O is the fixed point. And you end up with this equation, m dot S is R O cross U minus R. Remember, we had to remember that UO and UI are the absolute velocities of the mass entering and mass leaving and mass entering respectively. So what I have written here, in case it is too small, UO and UI are the absolute velocities of mass leaving Entering the system means entering this fixed volume which you are having. You know a equivalent word for that, control volume. Now this is informative, something which ChatGPT भी आपको बता देगा. But where lies its limitation is to solve the problem given there. So, how will you apply this and apply it to this particular problem at hand? So, this is the recap which we are having. Yes. How do you solve? So let us understand this problem. So here you are having water entering at some flow rate, and this flow rate is divided equally in these two outlets. O1 is one outlet, O2 is another outlet. And you know the respective areas at the inlets and the outlets. So what you will be able to compute? Velocities at inlets and outlets. So if you are trying to conceptualize, I mean this in form of this diagram shown over here, this part represents what here? The standpipe, the fire hydrant, with this and the boundary. And if you want to conceptualize it, you can imagine that a packet of mass here about to enter at instant of time t, which is delta m I. At t plus delta t, this. So what is your system? Like I said, all the fluid particles, this plus delta m I. At t plus delta t, what happens? This is about to enter, right? So at t plus delta t, this goes in. And then whatever particles who were there at the boundaries, they will now leave. So you can have mass packets leaving the boundaries. So this will be delta mi by 2 and this will be delta mi by 2. Okay, this is just I am trying to conceptualize as per this diagram. You need not draw these things, rather it will clutter the diagram just for the sake of representation. So this container, is it fixed or moving?
Fixed.
Fixed. So which equation you will use? 2. Equation 2, it comprises of forces. So tension and shear will be given by this equation, and bending moment you will get from this equation. Now if you want to use this equation, you have to get summation F. Now how do you think about summation F for this fire hydrant? So let us draw the outline or only the boundary of the hydrant. So once you isolate, what did I tell you in the note? Summation FF में क्या है? At the attachments there will be support reaction. So where is it attached? At the base, at the bottom. So here you will have shear force, you will have tension, and you will also have moment. Actually, I should not draw. Generally, I should draw it along positive k axis. Positive k axis कैसे है? It's into the. So okay, this is fine. If I get otherwise, I will get a minus sign. If the actual bending moment is to what I have drawn. And what else? So summation f में क्या क्या आया? B आ गया, T आ गया, और क्या आ गया? वेट आना चाहिए था फ्लूइड का, कंटेनर का भी वेट आना चाहिए, बट इट इज static pressure. Very good, that's a very good observation. Where will you have static pressure? At the bottom. So this static pressure P is distributed uniformly over the base area AI, right? So how much is the base area? So we will get E into AI. So now you are in a position to write this equation. So you can write U01. Here you can write so you in summation F you will write as per the coordinate system which is already mentioned in the problem. You can write V I cap because the shear force I have shown along positive x axis. Then P J cap, right? And then what else? And this is the left hand side of the equation. What you get for the right hand side? Ms dot. How much is Ms dot? What is the total flow? 10 feet into the specific weight. That is specific weight, so we have to divide it by mass. I mean, not mass, divided by G. Rho G by G, so that you get rho. So what did you have? You have total flow into the density. You will have mass flow. Now, the outflow is m dot s by 2. Plus there will be one more thing. If you look at it, already 10 feet, so m dot s by 2 is leaving from this end. M dot s by 2 is leaving from this end because it is saying is divided equally. And then what is u out? So you can write uO1 or you can m dot s by 2 is common, so use m dot s by 2 plus you need not write the bracket. Unnecessarily it will create confusion. Just give a minus m dot s into I, Vi. Ui is how much? U by A.
U not to resolve.
Yes, you need to resolve U naught two, but it is in vector form. So no harm here. But yes, you have to do that. U naught 1 will be first find out U naught 1. So it is 5 by 0.04. And what is U naught 2? So you are having 5 by 0.04 cos 30 minus I cap plus 5 this is also in feet square. How much are you getting U naught 1?
125
How much is U naught 2? Minus 125. Sin 30 is half. Now you substitute these quantities here. Also you have to compute what is P into AI. P is 120 pounds per square inch. Mind it, it is pounds per inch square. And what is the area? It is in feet. So 1 feet has 12 inches. So this you get in pounds. Mind it. Pounds per square inch. You multiply, instead of feet square, if you multiply with inch square, you will get pounds. Compute and tell me what is V and what is T. Now you know what to do, right? Anyone unsure of what to do next? I mean, all these things are given, you plug it here and equate I and J components on both sides. So after you substitute, you equate coefficient of iron shape. Yes, the guitarist. Are you getting? You play the guitar. It's okay. He's overall sound and vibration. The good thing about musical instruments and what they teach you is rigidity. What is the difference between string and a beam? Can anyone tell me? String and a beam. As a mechanical engineer, what will be your difference? Rigidity. So, if you have rigidity, you cannot produce sound. At least those frequencies are not in the audible. But if you are not having rigidity, string, you can produce sound. So it's important to lose rigidity, but in the process we gain more and more rigidity. You must be careful about why there is a minus sign. Have you understood? Just a random question. It's not a question, just forced question to see if you have understood. Minus human? Tabla is a membrane plate. Again, the same bending stiffness is not there. You play tabla? Music and mechanics go pretty much hand in hand. Okay, anyone with the answer? So please check if you are getting B as 162.5227 pounds. E as 12,612.730. Anyone who has got any of that?
Close but exact menu. 167 on
This one.
1260.
Should not. 162 at least you should.
162.27.
162.29. And T
12096.
T में इतना error क्यों है? T is J cap. Are you calculating the static pressure?
Yes, sir.
12354. 1. Can you tell me what is this static pressure? Can be a gauge pressure. That is how you express pressure. Yes, it can be a gauge pressure because otherwise we should have considered atmospheric pressures at the outlet. But more importantly, what is the source of this static pressure? In the tap also you have static pressure. तो पानी नहीं है तो हम लोग के घर में पानी कैसे आता है? Weight of the water column. So it's basically the hydrostatic pressure which is created by tank. Okay. Means the tank is placed at an elevated level and that creates a hydrostatic pressure difference. Sometimes to the tank, mostly it is done by a pump.
Sir, T12612.79.
Yeah, that should be correct. That is very close. 12612 you are getting.
12612.79.
Right, that is correct. If you approximate at every stage, you at the end you will get error. Do you understand? Okay, so how do we find the bending moment now? So which point we will take bending moment? Fixed point कौन सा choose करेंगे? B. This point, right? If you choose this point, then please solve the second part, bending moment. Can you understand this briefly?
Yes.
So here there are two parts, R cross U, and then there is Ri Ui. Ri cross Ui is Ui and Ri, no moment R. That point we have taken at the inlet itself. इनलेट पे लेने पे बहुत सारा एडवांटेज है, मोमेंट ड्यू टू टी, वी, स्टैटिक प्रेशर, एवरीथिंग इज zero. Okay. Even this part over here is zero. So only this part over here is only this particular. Please provide your attendance. OTP is